Hey everybody, thank you. So my name's Alan. I was excited to be the last speaker so I could get unlimited time, but unfortunately that's not the case anymore. I work as a systems engineer at Segment, and I'm here to talk to you about something that I'm excited about that I've been working on the side. This is a tale of two sessions. So this talk is for anybody who is into web development in Go. I know a lot of us are mostly backend programmers, but it's also for people who have no idea what a web session is. So what is a session? A session is a series of network requests that are often associated with the same user. They often have metadata, including things like the username and the label. So how do they work? Typically, you log in with a username and password, but you don't want to send the password with every request, right? Because it's kind of bad. So you set a cookie on the response header from the server. The client takes that and sends it with every subsequent request as long as it's valid, and it stores it until expiration. And there are two primary forms of sessions. There's stateful server sessions, and then there's encrypted cookie sessions. Here we've got an example of a stateful server session. This is the classic model. This is how things have been for a long time. You generate a session ID, you store it in the database, and then you set that cookie just like we saw before. It continues to send that, and if you have multiple web servers, they can be stateless, and it'll load that session ID from the database, and then it'll check to see if it exists. If it exists, then the user is authenticated. The other form is encrypted cookie sessions. Encrypted cookie sessions are picking up popularity in the last 10 years or so. But basically, you generate a secure key, and then you seed that key on all your servers. Then you use that key to encrypt some user data, including the user ID. And from there, you put that in a cookie, and then that cookie gets sent, just like that's how cookies work. And then after a different server receives it, it takes the key that it has, it decrypts it, and then it uses the user ID that's encrypted to authenticate the user. So the major benefit of this is just statelessness. You have one less database to manage. So let's talk about the threat models for this, because sessions, obviously are pretty big for security. Encrypted cookies are more secure because they're encrypted. This is something I hear a lot, but that's actually not true, right? Because if you steal an encrypted cookie, it's just as effective at impersonating a user. So as a side note, always use TLS and HTTPS. There's a secure attribute for the cookie, and that should always be set on session cookies. Second, secrets management. If you're dealing with web apps, you have to deal with secrets. For the server side, stateful cookies, you don't have any secrets. This is great. Your database should be firewalled, and it's a lot easier to manage. For encrypted cookies, you have this ultra secret key that's, if it's compromised, the attacker can impersonate literally any user, including your super admins and that sort of thing. So this is very often incorrectly implemented and dangerous. So I opt for simplicity, and I'm on the side of server side. Revocation. Server side, it's easy. You just delete a key in the database wherever you're storing it. For encrypted cookie, it's kind of a choose your own adventure, right? You just don't really know. You'll likely end up implementing something that looks like server side, which makes you wonder, why didn't you just start with that and then build on top of it? Now, it wouldn't be fair if I didn't talk about the benefits of using encrypted cookies, because there are some. They are good for server-to-server communication, especially within request-scoped context. So if you send a request to a server and it's fanning out a bunch of requests to your microservices, it's great for that because you don't have to worry about expiration or revocation. Additionally, it's good for federated authentication. So if you don't control the login server, then it's decent for that, but you still have the expiration issues. And finally, it can be used as a backup. I actually just learned this from one of my colleagues. And basically, if your session database goes down and it fits your threat model, you can use it as okay, we'll use this as a secondary authentication mechanism. And I thought that was pretty cool. So with that, introducing this new session management tool. So this is the entire API here. It's very, very lightweight. And you might ask why write another? There are so many out there. I think when I was doing my research, there's 6 different libraries for managing sessions. But I found that most of the existing ones, they're not very idiomatic. They work, but they're old. A lot of them aren't context aware, so if you want to cancel something and it's dialing a timeout to your session database, that's not a good situation to be in if you don't have context. They don't make it easy to clear sessions, so even though a lot of them, in fact most of them, use an additional database to complement whatever it is to store the actual sessions, they don't make it easy to revoke, which is, I think, problematic. And then a lot of them just have a really large surface area and pull in these other features that I don't really find useful. And then ultimately, I just did it for fun, right? This is a really simple thing to do, and I wanted to learn more about state-of-the-art session management. So this is an example of how you might use it. So here we have a login method, and you authenticate a user. If that user doesn't authenticate, then you send them a 403 or whatever, and then you set the session on that user in the database, and then you continue all happy. And then finally, in your main function, you instantiate a new Jeff, and then you can configure the redirect if it's unauthenticated, and you wrap all your authenticated routes. And that's it. Thank you.